Questions?
Is today all questions?
No, Wednesday.
Okay, all right.
Today is all questions. Tomorrow's all answers.
Did we ever learn what a card is?
A what?
A card?
Of cardinality.
Oh, is that what it is?
Shorthand.
Oh, okay. All right, never mind. Did we learn what a metric is?
No.
Okay. All right, that's all I have for today.
But what is a metric? Are you going to take 421?
Is that topology?
It's a good way to do some topology.
Okay.
Metric is just the idea of distance.
The distance.
And distance should be what? Symmetric. So the distance from between x and y is the same as the distance between y and x. Should be greater or equal to 0.
What's that with that?
Greater or equal to 0. The distance is 0 if and only if the 2 points are the same.
So what's that last one?
The distance between x and y is 0, means that x is equal to 0.
Okay, yeah.
And you have a triangle inequality. You go from A to B and then to C is longer than going straight from A to C. That's a metric. But if you have a metric, then we can define the idea of an open board or an open neighborhood, and then you can get the idea of open sets. And then you are in topology.
What's an open set?
Every point is an interior point.
What does it mean for every point of the interior point?
It's within.
There's a small ball around it that belongs to the set.
Okay. So it's a subset.
Yes, subset of something. So A is an open subset of X. If for every point in A there's a ball of a certain radius that also belongs entirely. That's probably the easiest way to come up with ideas of topology. So the first lecture may be to start with metric spaces and end up with topologies. Get the basic values.
You're teaching topology next semester, right? In the fall. So my next question is, if we take that class, will you pass us in this class?
But you'll feel
You will fail both classes.
I don't know if you have any difficulties passing this class.
This class?
Wait till Friday. We'll all be walking on the same.
Okay. More relevant question.
Do you have any questions, Bob?
Okay, then let's play a little bit more.
Just one question. So could you explain the idea of cardinality? How do we explain the cardinality of the infinite sets?
Natural numbers.
So, I mean, the principal idea is that we say that two sets have the same cardinality if there's a bijection between the two sets. So, if you have a one-to-one correspondence between elements, then you think they have the same number of elements. And that applies finite or infinite. And it's fine, I mean, that gives you an equivalence relation, because the composition of bijective maps is bijective. So the second question is then, when A has fewer elements than B. Because if you imagine you have an injective map from A to B, then the image has the same number of elements as A. Right? Because injective, if you just go to the image, it's automatically surjective. So you have this set, and in there you have a subset that has the same number of elements as this. So you think that this set, being a superset to it, has more elements, or at least as many elements. So then the question comes up of anti-symmetry. So you would like, generally if you have an inequality, one order, you could say A is smaller equal to B and B is smaller equal to A. You wanted the conclusion that A is B. And so that was a real theorem. That wasn't easy. That was Schrödinger-Darmstadt. So the question was what there?
There's one question is I'm saying that explain the idea of cardinality or define the idea of cardinality.
So cardinality is the attempt of telling you how many elements a set has. For finite sets, we have a good idea. For larger sets, we use such and such definitions. But it's kind of a problem where you ask, does the student have any idea what we have been talking about? So can you give a meaningful answer to that, in which case you give credit? If someone has no clue, then you say sorry.
It's like a gimme question, isn't it?
Cardinality is a verb.
Okay.
Cardinal. Cardinal, yeah. Cardinal.
Share. I'm glad that I didn't erase this stuff. It slows it down.
It's gonna put like honey on it so it gets real sticky and start to write it off.
Just throw away the chuck. Problem solved.
Our green chalk.
Don't do that. Maybe just okay and just slam it down. Just write in blood. Oh, you know, yeah. I got a question for Friday. Are we taking the final one here at the same time, or is it back in Keller?
No, I'm here.
It's gonna be here, same block of time, right? Okay.
So I was looking at some books where we consider congruence model numbers and put exercises there. So one of the questions in there was, so definition, X is congruent to Y, if and only if X cubed is congruent to Y. So question one is this an equivalence relation? Can be yours.
Symmetric and transitive.
So 3, yeah.
Yes or no?
If you say yes, you're gonna ask us to show it. It's the 3 properties.
If you say no, I say give me a contact sign.
No win, no winning.
So, yes or no?
Work through the 3 things and see if it works out.
Right?
It's reflexive. Should be symmetric too, right?
It's supposed to be an opportunity to write one sensible line, right? So if you look at 2, reflexive, symmetric.
Why 2? Oh, okay. 2 is symmetric.
You can fill in 1 and 3. So x equivalent to y means x cubed is congruent to y cubed on 4. This implies that y over cubed is congruent to x cubed on 4. Any argument needed? The difference is divisible by 4 and the sign doesn't matter.
Yeah.
So if you like, you can spend some time doing number 1 to 3. No. What are the equivalent classes?
If they're the same number, is that any Luke's class or not?
Well, the classes are going to be bigger. But maybe make a table. So you put x, you put x cubed. And then you put x cubed mod 4. So put the remainder. So if you take 0, you get 0, you get 0. Right? 1, 1, 1, 2, 8, 0, 3, 27. 3, right? 4, 8 is 64, which is 0. 5 is 125, which is 1, and so on, right? The statement is, if you don't quite know, then look at the problem concretely and possibly do some examples. That's the general advice. Have it done.
So when we put this class as powers of 2 or just multiples of 2?
So we ended up with
0, 2.
so 2 numbers will be the same if they have the same, if the third power has the same remainder, right? So we have 3 classes, even numbers, right? You raise an even number to the third power, you always end up with So what I want to say is here, if n is 2k, then n is equivalent to 0. If n is 4k plus 1, then n is equivalent to 1, right? Because if you raise this to the third power, you get something that's divisible by 4 plus 1. And if n is 4k plus 3, then n is equivalent to 3, right?
What about your 2? Does that count as an even at that point?
Yeah. If you have 4k plus 2, it's even, right?
Yeah, I think 2 is fine. And then that's it, because you can't have plus 4 will give you the 0. Yeah.
And you understand the calculation, right? If you take 4k plus 3 cubed, this is going to be something times 4 plus 3 cubed. And 3 cubed is 3.
What?
What?
27.
My fault.
Oh,
Okay.
okay.
Oh, yeah.
What?
I don't know. I'm 3 cubed. Equals to 3. Nothing.
You're ready to move?
Ignore the rest. Okay, so this is one of those typical problems that you should have no difficulty.
So can we expect this on the final?
I haven't even thought about it.
We have thought very much about the final.
Sure. But if you repeated this, x is equivalent to y, if and only if x squared is congruent to y squared. Not fun. Your response is, I know what to do, right?
Make a table.
First of all, you say this is an equivalent.
Who's waiting for him to turn around and throw the chalk at me? So.
I don't. Everybody agrees that's an equivalence relation?
Sure.
Same argument as we had at the moment. Right. And then we do make this statement. X squared, and x squared, 5, 1, 1, 1, 2, 4, 4, 3, 9 is 4,
4. Yeah.
4, 16.
Ooh, this is interesting.
Yeah. How many units starting this year?
I was wondering what I should, but I probably would have said, well, define this equivalence relation on the natural numbers, and then I wasn't willing to include it. So, but I would have liked the 0 up there, because you see this pattern, 0, 1, 4, 4, 1, 0, and after that it repeats, right?
Yeah.
So we will have again 3 classes, right? The remainder modulo 4 tells us was which class an element belongs to.
In mod 5.
Mod 5 is. But we have 3 remainders. So, one class is 0, 5, 10, and so on. Then we have 1, 4, 6, 9, 13.
Sorry. You just
Wait, wait.
define it.
We add 3, we add 2, we add 3, we add 2. So 11, 14, 16, right? And the other class where we end up with the remainder 4 is 2, 3, 7, 8, 12, 13.
Oh, I see. The pattern of dimension. Simple.
Right. And you did this type of reasoning back in 5th grade.
You didn't go to school.
Third grade. No, you'll see in a second.
For us, it's 12th grade.
No.
It's my first science.
And you learned actually one, well, I saw both. So when is a number divisible by 9?
It's a multiple of 9.
N equals 9k.
So like that, that's it.
Oh.
What was that?
Say it again, Mark. I agree with you. I'm behind you.
There's an integer k where n equals 9k. Or is it nk equals 9?
No, any of those
What did you
Yeah.
learn in 3rd grade?
My ABCs.
3rd grade.
What about
And, no, I mean, I don't know what the English word is, you can tell me.
The multiplication table thing? I don't know.
What?
3rd grade.
Quersumme,
What?
the sum of the digits.
Some of the digits.
Oh,
What's
Like,
the term for that?
if you add the numbers up
Yes,
and it's divisible by 3,
yes.
or if
Or
it's a
9.
multiple of 3,
Or
yeah.
9.
Yeah. I know what you're
So
saying.
what is the sum of the digits?
For the 9 case?
What is the sum of the digits? Is there a specific word for it?
No, we just call it the sum of the digits.
Okay.
Never told us. Square sum.
There is a term for that in German.
Oh, yeah, is there? What is it called in German?
Quersumme. Oh.
I think you just made that up.
So the sum of the digits.
I don't think I've ever heard of that.
It's German, that's right.
Is divisible by nine.
What? I'm not quite sure what you mean by that.
Like if you want to know a number is divisible by 3, how do you go about it? You add all the individual digits. Like if I told you 125, you would add 1 to 2 to 5, right? If that's divisible by 3, 5, 6, 7, 8, it's not.
Sorry, I'm not gonna get you there.
I don't get it. Oh, you literally add each one.
Number.
So the remainder mod 9 is
What is that? 33?
the remainder mod 9 of 3 plus 7 plus 9 plus 8.
Never seen that before.
I've never seen this before.
Never seen it
No,
before.
I never saw it.
No,
What?
I've seen it. I've seen it.
Yeah, I know.
I didn't learn
I've seen
this.
it.
What?
And in this case, it would be 10, 19,
Yes.
33.
27,
Oh,
33, right?
yeah.
So you get a remainder of 6.
Never seen that.
No.
Maybe you did.
I mean, the same is also true mod 3.
Yeah, that's the only case where it works, all right. Adding the digits thing.
No, no. I mean, the things that they do before, even,
If the number on the end of the 2 is an even number.
last digit is even, right?
Yeah.
Divisible by 5.
Oh, last number is a 5 or a 0.
Last digit divisible by 5, right? If you want 25, you say last 2 digits.
Divisible by 5.
At 25. Divisible by 4, the last 2 are divisible by 4.
Really? Never heard that one.
Divisible by 8, the last 3 are divisible by 8. Right, I mean, if you have 7, 9, 5, 8, 2, 4, this is congruent to 824 mod 4. Mod 8.
What? I don't know what you just wrote. I missed it. 795824.
Is congruent to the last 3 digits multiplied.
Oh, the 824.
So the remainder is the same. So divisibility by 8, you check by looking at the last 3 digits.
That's weird.
So
it's
here you, for divisibility by 2, you check the last digit.
Yeah, okay.
You said it's even,
Yeah.
divisible by 2.
Sure.
If you want divisibility by 4, look at the last 2 digits.
Okay, wait. So 24.
So 318 is not divisible by 4.
No. It was a 16. It was
18
not.
is not divisible.
If it was 316, it would be right.
Right.
Okay. So is 824 divisible by 8?
I don't know. Yes, it is. This is 103, right?
Yeah, 100 beats the 800. But yeah, 20%.
But the point is 795000.
Divisible Divisible by 10?
This has
For
3,
1,000.
yes, it has 795 times 10 times 10 times 10. And each of the 10s is divisible by 2.
Oh, okay, this is by 8.
Yeah, because
Oh.
824 is divisible by 8.
I think he's talking about the bottom number.
Oh,
This number here is divisible by 8 because you have 3 times the factor 2.
oh, I see. So basically, you're just saying to factor out 2 from each one of the.
Yes.
Okay, got it.
Clever.
Oh, they played incredible games with it. In particular, people like Oriole. So, do you understand why this one is true? So, 10 is the same as 1. Or 9, right?
Yeah, add 1.
Yes.
100 is the same as 1. 9.
Yeah.
So 100 in here, for 800 you can replace by 8, right? 800 is 8 times 100. This is congruent to 8 times 1 because this is the same as this.
Times 1 is divisible
100 modulo 9 is the same as 1. Okay. 100 is 99 plus 1. And 99 is divisible by 9. Well, people always say there is no test for 7 or whatever, but you can make up the test. By the way, what's the test for 11?
I don't remember.
When is a number divisible by 11?
If 11 is a factor.
Hey. So if you have A0, A1, A2, A3, A4, A5. So these are your decimal description.
Position.
So if this is X, so X mod 11 is the same. Or let's say X is the same as A0 minus A1 plus A2 minus A3 plus A4 minus A5.
This is going to be on the final.
Nobody. Oh,
Yes.
Okay.
why is this? You see here we said this, right? So what can you tell me with 11? So 11 is minus 1 more 10, right?
Oh, you're adding 1.
Actually, I want to write it the other way around. 10 is minus 1 mod 11. which is 10 squared, is minus 1 squared. Right? 1,000 will be minus 1 modulated, right? You just calculate with your classes. You can do representatives, right? This one here is minus 1 cubed, right? Because 10 is negative 1.
See a pattern.
So, for the tens or the thousands, you need a negative. Okay, and for the even powers, you need a plus, right? 100
Oh, yeah.
is
1.
modulation. 10,000 would be 1. And this principle was just that you don't need the whole number, you just reduce the remainder.
To do your little test, that's what you're doing.
Or to calculate the remainder.
Ah!
You got it?
No. I've seen something like that where they give you some giant number and they tell you go find the remainder of it.
Yeah, that's pretty easy anyway, right?
Well, no, if the number is like a really long string, and you'd have to sit there and, if it's a simple case like 2 or something, you can spot automatic, but what if it's something nasty?
They made me do long
So
division.
5 was 7.
Try it for 7, like find one for 7, or?
Yeah. I mean, any of your, somebody was asking me earlier, did you ever teach 1/12? And I said, no, absolutely not.
Teach what?
Math 1/12. I mean, this course for elementary majors.
Okay.
And the book kind of insists that there is no pattern for
7.
7. But let's make one up. Okay. So, mod 7. 10 is 3 mod 7, right?
Yeah.
100 is what? 2 mod 7, right? Correct.
Yeah.
But you shouldn't have calculated it this way. 10 is 3. 100 is 10 squared. So that's 9.
Yeah.
And 9 is 2 mod 7, right?
Yeah.
How about 1,000?
9 is 2 months 7.
Okay, I kind of get it.
1,000 is 10 times 100. So this is 2 times 3, right? If you want, I don't know whether this one can calculate your numbers.
No, you need mine.
I really want to take decimals. So it's 10,018? Shoots.
I'm gonna break apart these.
Oh,
things, right?
shit.
Sure, it's 18, but 18 is 4, right?
Yeah. 4 months.
40
Yes.
is divisible,
Yeah.
right? So, 100,000. Right. 100,000 is 2 times 6
Oh,
is 12, and 12 is 5, right? The median is
One. 117? I don't know. I could be wrong.
okay. Right. And after that, it will repeat.
Okay.
Okay, because this corresponds to the case 10 to the 0. So A0, A1, A2, A3, and so on. You can replace this by A0 plus 2A1 plus, 3A1 plus 2A2 plus 6A3 plus 4A4 plus 5 A5
Plus A6.
plus A6 and so on.
I was wanting to know how to solve that problem when I saw it. I was like, the only way I ever knew was by simulation, but you gave a clever way to do it.
Okay. Actually, there's a lot more I wanted to do today, but I will probably leave you with one job intervention or homework.
Oh, we're gonna have homework?
The one question was,
Oh, we're not gonna get it back though, yeah.
when is this appeal? So when do we have multiplicative inverses? Okay, and you remember we did some examples where we said the 6 is not a true, right? And maybe we did the 5 is a field.
What is Z of 6?
Yeah, you
Oh,
gotta
what is
find
Z of
that.
M? What is
This is
Z
Z
of
subscript or something. What is Z of M?
This was Hongen's classes modern, right?
Oh, okay.
Oh,
Modular arithmetic.
Okay.
I'm just talking modular arithmetic. You remember the table you made, right? And sometimes we had inverses or not. And I probably shied away from giving you a criteria. So, what is the question?
to be or not to be?
So, given x, not divisible by n. When can we find y so that xy is equal find a multiplicative inverse. I do think that at the time I kept it secret. So the statement here would be that xy is plus m times k. Right?
Yeah.
So this is given, and this is given, right?
Excellent.
But
You want to find y.
and some k should do it. We don't care.
Yeah.
So does anyone recognize that expression?
Is it a line? No, no, no.
So,
We talked about that expression last week.
common divisor.
Oh, the linear combination? No.
Yes. Right. Greatest common divisor, so we need. So this is possible if the greatest common divisor of x and m is 1, right? And this is possible for every x. If m is
Ooh. Yeah.
okay, so Z5 will have inverses, Z6 will not. Z13 will have inverses, or Z11.
This is a product piece.
Okay, so I do want to give you evaluations, but let me give you a problem first.
Cool. Is that the great
7
piece?
pirates.
Oh.
No, 3 pirates. No, 7 pirates.
Should we write this down or no?
Yeah, 7 pirates. They try to divide their treasure. And at the end, everybody gets the same number of coins, but there are 2 coins.
Wait, say that again?
Everybody, they are like the ones, okay? 1, 1, 1, 1, 1, 1.
Okay, so they kind of count out the treasure.
Right, they count out the treasure. And they're left with 2 coins.
One at a time. Left with 2 coins.
So, what happens?
Split the
One
coin.
pirate is very adventurous. He takes the 2 coins, throws them overboard and says, now it's fine, right?
Yeah. I would have killed him. I would have popped him.
Only they're pirates, right? They take him and throw him overboard. Okay, so they try the same game again.
With the remaining coins?
No, yeah, so two
Oh,
coins,
6 people.
2 coins are gone, 1 pirate is gone, right?
Okay, yeah.
So now you have 6 pirates left. They again try to count them up.
Yeah.
Now they're left with 3 coins.
Yeah.
So they get back into their fight. 1 pirate goes overboard. No coin.
So does it 3 coins overboard too?
No.
No, they keep the treasure, but they're losing people as they go.
Okay. But the first one they lose 2 coins
Yeah,
overboard. Okay.
yes.
Alright.
I've heard of.
So now
Sounds like the freaking monkeys on the
with
go.
the 5 pirates and 2 coins left, things work out.
Oh, yeah.
Five pirates, things work out.
How many coins did they have at least?
At least 9.
No, I think it's more.
It's something on five, right?
So if you started out with 9, then you are left with 7 thereafter. But you had 6 pirates and 3 coins square. So that doesn't work.
Okay.
7, 8, 9. I see weird guess for 9 is.
14.
14, then it would have worked out.
Because it's divisible by 7.
Okay. Yeah. Oh, no, sorry. 16.
16 and 14 coins would have been left. For 6 pirates, that means 4 are left, not 3.
Okay. 23.
You pick
By the way,
45!
that's about the Chinese remainder theorem, right?
It's okay.
I know a different
So
one.
in the 3rd century AD
Yeah.
or CE or whatever we call it, some Chinese gave that as a problem.
The one that I saw was there was these prisoners, and they decided that every second prisoner would get executed. And so who's the last prisoner standing at the end? Like what position would you have to stand in out of like so many
But
prisoners?
that's different, right?
Yeah, it's different. You have to calculate really fast.
Okay.
That fails the 7 pirates, so.
Feels so.
Or no, never mind.
So if you
6
want, we
pirates,
solve
so-
it now.
Wait.
Otherwise, there will be evaluations and you can entertain yourself. But if you Google Chinese remainder theorem, they probably explain to you how to do it.
Okay. Is it a pretty large number?
I think so, at least if you learn.
It is a
Oh,
lot.
okay.
What's your answer?
23. Oh, wait, what would I ask just now?
Yeah.
Is it a large number?
Yeah.
You can think about it, let me say.
That's what I'm gonna write on my paper. It's a large number.
Maybe it's not large or something.
So X.
Shit.
So 7 pirates. 2 coins left, right? 6 pirates.
It's 2 months, I think.
3 coins left. after minus 2, right? Yeah. And then you have 5 pilots, and it works. So if X is a number,
Pirates.
no, number of points. Then X is congruent to 2 mod 7, right? Because you were left with 2 points.
Yeah.
X minus 2 is congruent to 3 mod 6. And X minus 2 is 0 mod 5, right?
Oh, I see.
Agreed?
Yeah.
So if you write this as X is congruent to 2 mod 7, X is equal, congruent to 5 mod 6, and X is congruent to 2 mod 5. And then what you can do is you say X is 2F1 plus 5F2 plus 2F3. Because I took the remainders and I put them here.
What's the F1?
You see?
I'll tell you in a second.
What's that?
F1 is 1 mod 7. F1 should be 0 mod 5. And F1 is 0 mod 6. So I want to find some number like this. Then I'll make F2 is congruent to 0 mod 7. F2 is congruent to 1 mod 6. F2 is congruent to 0 mod 5. And F3 will be 0 mod 7. F3 will be 0 mod 6. F3 will be 1 mod 5. So, if you find an F1, 2, and 3 like this X would work. So let's do this. How do you get a number which is 1 mod 7 but 0 mod 5 and 6? So it must be divisible
6
by
and
5
5.
and 6.
Yes,
Right?
those are 2 terms of it.
So it could be 30.
Okay.
Sure.
Or 60.
Yes.
Or 90.
Okay.
But you have an extra
Or 120.
Yeah.
Okay.
Well, you could also start with 0.
Oh, 120.
But that one doesn't work, right? This is off. This is off. 90.
Nope.
No.
120.
How about F2? It should be divisible by 35. That doesn't give us 6, right? It gives us, well, minus 1. So 70 Yes.
6, yeah.
Wait.
Yeah, 112,
Oh,
minus
minus
6.
Okay, yeah,
6.
yeah.
And F3, it should be divisible by
76.
42.
Wow.
Holy shit.
I got this.
84, no. And 126.
Yes, right.
Yeah.
So 6x to be 2 times 120 plus 5 times 105 plus 2 times 126.
Oh.
So what is that?
That number works, right? When we reduce
It's like
modulo
1,000, right?
7, this part and this part will give you 0, right?
1017.
But if you, I mean, this number, this number is divisible by 7, and this number is divisible by 7. Right? So this part is divisible by 7. Here you get a remainder 1. So twice this will give you a remainder 2, right? If you look at 6, this is divisible by 6, this is divisible by 6. So the remainder modulo 6 will be the remainder of this. This has a remainder 1, so you get a total remainder 5. Right? Therefore playing with complexes. The Chinese did that already 1700 years ago. Teaching a little bit.
Oh, is this, are these surveys?
Is that time?
Yeah, the semester's almost over.
Wait, what?
Evaluation.
It's really a test for us. Some of the quiz.
So you bring it to
Okay, alright,
Matt
together.
Department office.
You gotta take it to his office, not his office.
Matt
here.
Department office.
4th floor, next to the stairs, right?
Right.
Yeah.
So,
Oh, is this
are we
just-
gonna negotiate now?
Yes.
Hey.
Okay, it's 2:00, man.
So what do we get if we fill that thing up real positive?
I don't get to read it until I have submitted the grades.
We'll go by honor.
They have-
Your odds would
You
improve.
know, under privacy rules, I cannot tell you what grade he got in math 307. He can't tell.
Okay.
Yeah, if I had $20 in my pocket, you know, this thing might.
Okay, see you Wednesday.
No,
See you
you-
Oh, that's it for, oh.
What section are we?
There's only one section.
Okay.
No, they might have put a different number though.